Let's take a look at this problem. Types of raw material used to construct stone tools found at archaeological site, Casa del Rito, or shown below. Random sample of 1,486 stone tools obtained from a current excavation site. Okay. So it looks like we got raw material. Basalt. Obsidian. I was saying those wrong. Welded tuff. Pedernal chert. Other. I'm pretty sure I'm saying that one right. Okay. And this says the regional percent of stone tools. So I got 61.3. We got 10.6. 11.4. 13.1. 3.6. And the observed number of tools at the current excavation site. So this is the current site. This is also our observed. And we've got 906, 162, 168, 197, and 53. Now if we add these together, 8, 16, 19, 26, carry the 2, 8, 14, 19, 28, 2, 9, 10, 11, 12, 13, 14. That should match how many they told us. They told us 1,486 tools. Okay. And alpha is 1% level of significance. So alpha is 0.01. Test the claim that the regional distribution of raw materials fits a distribution at the current excavation site. Okay. So the regional distribution proportion or percentage, however you want to think of it, is the same as the current site. Okay, let's look at our steps. Step 1, write down a shortened version of the claim. Well, that's what we just did. Come up with a null and alternate hypothesis. H0 has a probability for each category. So this is going to say that P1 is equal to 0.613. P2 is equal to 0.106. P3 is equal to 0.114. P4 is equal to 0.131. And P5 is equal to 0.036. And H1 says some or all the probabilities are different. So some or all are different from those specified in H0. Okay, well, our claim is that they're the same, and that would mean that we're asking about H0. Okay. Now this says, put observed into L1, expected in L2. Well, our observed L1 is these right here. So we got 906. We've got 162, 168, 197, and 53. Now our expected, we're going to put into L2, and that's going to be N times P. So we'll take 1,486 times 0.613. We'll take 10.6%, so 0.106 times 1486. We'll take 0.114 times 1486. We'll take 0.131 times 1486. And we'll take 0.036 times 1486. Okay, let's see what that gives us. 0.613 times 1486. And we round like normal, so this will be 911. 0.106 times 1486 gives us 158. 0.114 times 1486 gives us 169. 0.131 times 1486 gives us 195. 0.036 times 1486 gives us 53. A lot of these kind of look really close, so it'll be interesting to see what this test comes out with. Okay, so let's go put these in the calculator. So go to my stat, go to edit. Okay. I'll clear out those two lists. In L1, we'll have our observed. So we got 906, 162, 168, 197, and 53. In L2, we'll have our expected 911, 158, 169, 195, and 53. Then we'll exit out, do second mode. That was step 4. Put expected in L1, or observed into L1, expected into L2. Now we're going to do chi-square goodness fit test. And our degree of freedom is number categories -1. Well, we got 5 categories here. So 5 minus 1 is going to give us 4. So let's go to our calculator. Press stat. Go over to tests. Up arrow until you get chi-square goodness fit test. Not every TA3, well, TA3s definitely don't have it, but not every TA4 has this function. So if yours doesn't, you're one of the unfortunate ones that has to do it by hand. And I did put an example of by hand in this lesson or section. So I choose that. Observed is L1, expected is L2. Our degree of freedom we just said was 4. Go to calculate and press enter. And we got our P is equal to 0.9971. Okay, if p-value is less than alpha, it's not less than. If p-value is greater than alpha, accept h naught. So we're going to accept h naught. And since claim matches h naught, whatever we say about h naught is what we say about our claim. So we'll accept our claim. Which kind of makes sense when you think about it, because we said they're the same, and these numbers came out really close. Only one that's a little bit off was these first two, and not significantly, I wouldn't say. So that explains why you have such a high p-value here.